and have to subtract 4x, my other option would be to add 8x to both sides. You can do either way. It doesn't have to be. You just have to get them together. That allows this to become 0, and all I have left on this side is a negative 17. This is why I like to draw the line, because now we have stuff going on the right side and the left side. Alright, so on this side, a 7 is going to drop down. I have a negative 8, take away 4 more. That's going to make negative 12x. And now this is just like the ones we've been working on. Now I need to get rid of the 7. I need to move it over here, so I'm going to subtract 7. And then I'm going to bring down negative 12x. I have negative 17, take away 7 more, would be negative 24. And then I need to divide both sides by negative 12. So x would be positive 2. Okay? Alright, make sure you have number 2 written down, and we'll go through that one together, because this one throws people a lot of times. That's why I put it up here. Okay, so you have two options. You can either add 3m to both sides or take away 5m from both sides. But if I take away 5m from over here, remember when we talked about the teeter-totter? What happens if I take all the kids off one side of the teeter-totter? Yeah, it goes down. It doesn't help. I'm unbalanced. So on this one, my only option really is to go ahead and add 3m. So that the 24 comes down. This becomes 0 and drops out. The other side I get 8m, and then I can divide both sides by 8. Everyone's writing this, right? Like, I know how to do it. So, okay, just making sure you guys are writing down. So that
it's like the stuff that we just got done doing.
it is.
Except you just have one more like number again.
You do. You have one more step on these. Yep. All right, so you're telling me I can go faster. No. Yes. Well, then if you guys feel that confident, I might skip those two then. Let's go to these then. No, you couldn't have. We did those two. We'll move on to this. Yeah, we'll do these. I know the numbers are probably, well, maybe, yeah, they're wrong, but that's okay. So this should really be 3. This should really be 4. Okay, so now let's tack in distributive property and see there's something else that might happen on these that might cause you to not know what to do. Okay, so this side's going to say 9z plus 12 equals 9 times z is 9z. 9 times 3 is 27. Okay, so now I'm going to go ahead and subtract 9z from both sides. So subtract 9z, subtract 9z. What happens now? What happens to all my z's? They're all gone. This right here is canceled out, so all I'm left with is a 12. This right here cancels out, all I'm left with is a 27. Okay? When that happens, okay, there are three things that can happen in any equation. There can be a one answer, which is what we've been doing. There can be basically a no solution, or it can mean all real numbers in the world. Okay? 12 does not equal 27. Okay? Think about this. Is there any number I can plug in for z, multiply by 9, and then add 12, and get the same thing over here if I multiply by 9 and add 27? If I pick a number and plug it in here, and multiply it by 9. So pick a number. 3. 3 times 9 is 27. If I add 12 on this side, and then I add 27 on this side, these two sides don't equal each other. Does that make sense? So that's why when you get to this and you're like, 12 doesn't equal 27. That doesn't make sense. That can't happen. So this is a no solution. There is no number that I can put in to make this equation work. No solution. All right, let's look at number 4. All right, so on this one, do you want to subtract 7w or subtract 8w? 7. My 7w? Okay. Alright, so on this side I have 1 equals 1w. And then what do I need to do to both sides? Subtract 1. And then this always confuses people, because what does this mean? One minus 1 is 0. For some reason, once we start talking about no solution and things, people don't think you can have 0 as an answer. 0 is an answer. That's perfectly fine. Okay? So you can have one solution or a 0. You can have no solution. Or you can have something else. Alright, so this would be example 5. I'll change that. Alright, so we're going to distribute. So this would be 6a plus then 3 times 2, 6 equals 2 times 3a is 6a.
Whoa, that's equal right there.
That's equal right there. So what's that going to mean?
You don't have to do anything. That's your answer.
It's all real numbers. And remember when we talked about real numbers are every number in the world. Okay? So if, oh, whoops, I said 6, but I wrote 3. Sorry. Okay, this side is the exact same as this side. So it means every single number in the world that I choose will make this equal. Okay, so let me go over this again. When you're doing these equations, you can have one solution. One solution looks like x equals 5, or x equals 0, or x equals any number in the whole world. That's one solution. Okay? You can have variables drop out, and you can have, like what we had in the notes where we had this, and that meant there was no solution. Okay? Or the third thing can happen, and they're basically the same equation on each side, or you might work it and get something like this. You might get 12 equals 12, and that's true, instead of getting this one, and that would mean that it's all real numbers. Okay, so those are the 3 different scenarios you can get when you're solving equations, and all of that will happen today as we're practicing. Okay?